what we've got here, two electrical guys talking about something not exactly electrical. Why? Because subject, which Sunny, and here is Sunny, and my name is Ark. Sunny will discuss, deals with specific requirements of energy efficiency code. But those requirements are designed by electrical designers, installed by electrical contractors, accepted by, so far we don't know whom. Who is enforcing it? How is it done? And are we consistent on this issue? So this particular subject will give you a flavor in understanding legally adopted codes and how implementations of these codes is important in your life, because it is a law and it has to be met. Sunny, maybe you can show briefly what we've got on our agenda, and then I'll deal with purely electrical aspects.
So just a bit of background, what we're going to start with is code or a standard. It's very easy when we talk about code, we all relate to life safety, we talk about fire alarm, and when we talk about energy, it's not really framed in the context of a code. So that's what we're going to talk about, and Ark will jump right into that. What's applicable, when and where? In the city of Vancouver, it's probably the most confused topic. People are confusing the Vancouver building bylaw with the BC released energy code, whether it be ASHRAE or NECB. We'll talk about some of that. LEED version 4, it's not a LEED seminar, but it's to give you an idea of why you need to understand the energy codes and how it relates to LEED project or not. What's new in ASHRAE? The next one after that is who cares and why should we care? And we always get somebody in the back of the room that says, how do I not have to comply? So get me the out of jail card. So we'll talk about that. There always has to be two methods, right? So they put a Portman bridge in and put a toll on it. You could take the patillo. You might spend half your life on the bridge in traffic, but you could take it. So this is an alternate compliance, and we'll talk about how it's relevant, if at all, and then the next steps and how we actually move forward. So getting right into it on the code safety. So Ark.
Sunny mentioned a couple of words. He said fire alarm system. Is fire alarm system mandated by any code, in your view? Which code? Building code. Fire code deals with maintenance of already installed fire alarm system. So fire code is a follow-up document. But which legally adopted document mandates fire alarm system in a building? Guys, speak up. No, electrical deals with wiring. Section 32 deals with wiring. And Section 32 says, scope of Section 32 deals with fire alarm systems required by National Building Code of Canada. So building code mandates it. And yet, who designs fire alarm systems? Electrical. Electrical people have to read Section 3 to 4, Section 3 to 6, life safety system, Section 3 to 7 of the building code, have to understand, have to put all those components on electrical design drawings. And who will install it? Electrical contractors, of course. They look at electrical drawings. Because installation, in addition to building code requirements shown by electrical designers, has to comply to what installation standard? Anyone who's doing electrical design, Yuri, can I pick on you? ULC S524, because ULC S524 tells you where particular components of fire alarm system must be installed. Electrical code is ignorant on that stuff. So you can see electrical designers have to deal with lots of aspects which are not necessarily part of electrical code. But what Sunny said, code mandates those requirements. So those requirements become what? A law. And we have to abide by requirements of legally adopted codes. What is interesting? Fire alarm system, electrical system, those are safety installations, safety equipment, and safety is regulated. Compliance with safety is mandatory. However, in society, we're growing. Mentally, spiritually, socially. We take more responsibilities. And building codes reflect those responsibilities. So building code has a number of other requirements for sustainability, energy efficiency. And when those requirements are adopted, they also become law. And we have to comply with the law. What happened traditionally, we take in cavalier attitude because it's not building code, it's not electrical code, it's something else, which is not really tangible. And as Sunny said, many people don't understand to what extent you have to deal with it, because it's not safety. Try to violate safety, you can understand implications could be tremendous. But we deal with sustainability. Now, how people understand those requirements? Is there a confusion? Of course it is, and we can see how many people here. And they want to know, and you want to know because you don't want to make any mistakes. Why? Because you don't not only want to comply with the code, but you understand objectives. What is intended by this rule? What slide Sunny put on a board, it's electrical safety system. Canada has a very unique entity. It's called electrical safety system. Nobody in the world, and you can challenge me. And the reason why, because only in Canada we have extremely comprehensive, integrated system where product standards become basis for design of any products. And Canadian Electrical Code, which is installation standard, mandates that only approved products must be installed. Approved, it means, or they are certified to CSA safety standards or to ULC safety standards for firearm system. Certified by accredited certification organizations. And accreditation is done by Standards Council of Canada or by means of field evaluation, special inspection, to CSA code SP 1000, some of you know. So you can see three components: products, accreditation, and codes and standards. But what unites those components in one system? Regulatory regime. Because electrical inspectors across the country at each provincial and territorial level, because electrical safety, it is provincial territorial responsibility. They will ensure that you install only approved equipment, and not just approved equipment, but equipment which is approved for this specific location. If I want to install something outdoor, it must be in such enclosure which will take rain. If I will install something in a paint spray booth, it must be specifically approved for this location. So it's exactly what designers have to know, contractors have to know, and of course inspectors. And it is very comprehensive integrated system which allows us to do it. And inspectors also check whether installation of this equipment is done in accordance with installation code. Nobody else. In US, it's not mandated. In Canada, all electrical inspectors, all chief electrical inspectors for provinces participate in development of the code. And then they adopt this code for regulatory purpose in their jurisdiction. And many of us participate in this development. So you can see. But what Sunny talks about something absolutely unique, where all those integration components are not very well defined. And you can see exactly we're mandated now to comply with ASHRAE 90.1 or with Energy Code. And yet, who is enforcing? Who is complying? Are we, folks, I saw hands, in design area, are you all diligently complying with these requirements? And do you know what implications will be? Are you clear what's supposed to be done from electrical side? And what kind of impact? And second, who is enforcing if majority of these requirements are done by electrical designers, installed by electrical contractors? Who is enforcing? Any idea? Nobody. Where is my main component? Regulatory regime doesn't exist because enforcement is just in stage of inception. Nobody knows how to deal with it. So what we do, and Sunny will talk about self-declaration, and Sunny will explain specific component which deals with commissioning, validation, verification, what was done by design and installation. But if you ask regulators, are you enforcing it? They don't know how. They don't know who will do it. Building inspector says, it's not my responsibility, I don't get paid for it. Electrical inspector says, I'm enforcing electrical code. I was trained in electrical code. I'm an electrician. So you understand, we are at a stage where all these requirements are built together as a system. I'll give you another before I'll transfer everything to Sunny, because he will deal with essence, with meat and potato. I'm just an opening act for him. But what is interesting, Sunny talked about performance requirements, and Sunny and I, we just talked, City of Vancouver introduced another requirement in the building code. We just talked about electric vehicle infrastructure. How many people here have electric vehicles? Out! Everyone. You understand? And yet, city mandates in building codes electric vehicle infrastructure. Question is, do we have to mandate this stuff? It's convenience. If I want jacuzzi in my house, I will install it. If my house has insufficient service, I'll spend money, rip apart my existing service, install new ones. How far do we mandate? But society has to acknowledge. So City of Vancouver Council recognizes importance of this stuff. And now it says, let's say 20% of every parking stalls now in commercial, not only residential, must be provided with infrastructure. It's a great intention. But does it work? No. Because charging system changes every day as we speak. Nobody will plug in 20-amp receptacle your charging system and wait for 18 hours. You don't have time for it. Everything is changing. But it was a good attempt, which so far created lots of problems for designers, for contractors, and for owners. But we're not here to discuss this stuff. What we wanted to show you is that certain things are mandated, but mandated with specific objective. And we as a community have to or challenge something which is mandated or improve those requirements which already exist. So after I said my piece, I'm really happy to introduce Sunny, who will give you a flavor of energy efficiency requirements in respect to lighting control, other types of controls, everything we wanted to know, but always afraid to ask. Here is Sunny.
Again, thank you very much for coming out. Brief introduction on both of us. Ark used to be with the City of Vancouver. He was the Chief Electrical Inspector for the City of Vancouver for the longest time. Every policy, every code, every CSA document, ULC document in North America was written by this gentleman. So we're blessed to have him on our team. He's been, he left his 20-year career at the city about 2-3 years ago and decided to join a larger firm, and since then has joined us about 1.5 years ago, and nothing but great things. Ark used to be an electrician as well, so he comes from the world of install, regulatory, and now is on our side of the fence where we're talking about design components. My background, I've been in the business since '93, about 21 years in practice, 15 years in the design capacity in building engineering and sawmills. Prior to that, electrician and general contractor as well. So I've been on the tools, I've built projects, nothing as big as something like this, but we've done the general contracting side of it, and now we're on the installation side of it. So I can speak and relate to some of the issues in industry, and the idea here is to go through something that is very confusing because it took us about 2 years to figure it out. The other bit of background on myself, I used to be on the executive board for Cascadia chapter for CAGBC, and we actually started that chapter when we were at Keen Engineering about 12-13 years ago. So the green movement, as we call it in BC, or as the rest of Canada calls us, the tree huggers, we've been part of this for a very, very long time. We've been trying to implement it within the building code for a very long time. So in meetings and subsequent meetings with the minister and the ministry and the government currently in power, they decided to adapt this and enforce it in the building code, which is beyond just a LEED project or LEED Gold project requirement. So we'll get right into it. This is the only plug of the day. AES and what we're about, we're an electrical engineering firm. The best way I could describe our firm is we are a boutique electrical, architectural lighting, and technology firm. So we can put an air handler on the roof and we can connect power to it. Great, we can do that. We'd love to get it. We'd love to get the fees for it. The world that we really play in is a live-in building world. So live-in building, LEED Platinum, LEED Gold. There are 6 living buildings in the world right now. We've participated in 2 of them. We're starting our 3rd one right now. LEED Platinum, slam dunk, LEED Gold, no problem. I think to get a permit and do a project in BC or in Vancouver, almost everything's going through a rezone process. LEED Gold is a minimum requirement. So the world that we play in is on that edge, but we can put like I said, put an air handler on the roof and give you a service. The firm itself started in 2001, provide all the services under Div 26, 27, and 28. Some of the projects we do, we finished the largest DB in British Columbia, the Canada Post relocation over to the airport. We just finished the aquarium. We do a lot of aquatic facilities. We were actually the engineers that worked on this one in a joint venture with Shanky back in 2002 at Keen Engineering as well, so very proud to be in our own facility. So we do projects large, we do projects that are small as well, but very specialized type firm. Offices in Vancouver and Victoria, 42 in Vancouver, 18 in Victoria, and we do everything on the island in BC. We do travel abroad as well. We do work in Alberta. Recently came from a commission in Melbourne, Australia, in Mongolia, China, and now we're out to India as well to do a PV installation for about 2-3 megawatts. Actually, 200-300 megawatts. The scale over there is way bigger than what we do here. Architectural lighting design, we do have IALD and LC professionals on board. We are going through a credential change right now. The credentialing is changing from LC to CLD. LC is open to everybody. CLD will be strictly for the designers and won't be open to other people in the community, in the design community, such as suppliers, etc. So they'll be looking at reforming some of that, so we've got those on board. RCDD professionals, I think the smarter these devices get, the dumber I get. I can't remember what I'm going to do at 3 o'clock, but this will tell me. And the world is going on the network, so as I walk into an office, and we designed many systems actually. 745 Thurlow, one of the buildings we've commissioned and designed, and it's going to be opening in about 2 months. The owner in the building or any tenant in the building can drive into the parkade, the gate opens, they get into their parkade, don't lose signal while they're on their phone with whoever they're talking to, get through the elevator, get up to their office floor, get to their office, and by picking up signals through the IP on the phone, everything turns on and off as they go through the building. And that is the world we are in. Is that technology available? It was available 10 years ago, cost a lot of money, didn't work half the time. Now it's available, it costs much less money, and it's very, very much more reliable. AV design, sustainability, I think sustainability is minimum requirement in British Columbia, so I won't talk through that. And ULC, CEC, CSA, NBCC, any of those code requirements up there, again, it's Mr. Tsisserev, and he's the gentleman that gets us through and puts our name on the board. And we're very proud to announce the new Canadian Electrical Code for 2015, which is going to be adopted in BC in September, I think, or August. We're the chair of the committee, and very proud to say we've helped and pretty much written the new code. So any questions, please call him, don't call me. I just take the credit. So let's get right into it. What's applicable, when and where? We'll talk about yesterday and since December 2013. Just to give a background to this, ASHRAE 90.1-2010, we've actually studied when it was released in 2010. There were some challenges with it, so we issued amendments to ASHRAE, and we asked them to clarify some of the items. And we've been designing to ASHRAE 90.1-2010 since 2012. So when we started designing it, we found a lot of flaws in it, and we wrote back, and we found fixes and remedies and interpretations that make sense in how we're going to deploy it. So in 2013, in August, we started presenting to everybody in the city. We've got a few clients that I've presented to that have decided to come and listen to it all over, so catch me if I'm wrong. I probably will trip up on this. We presented to architects, owners, engineers. We recently, through some of the connections Art brought in, we presented to the Contractors Association of British Columbia, and 2 weeks ago we presented to all the inspectors in British Columbia, EIABC. So we're talking to everybody so that everybody understands what it is about, and we want to remove the confusion that's come up with the implementation of some of this. And by all means, if you've got questions, please, I'd love to hear some of it. 2007 was the Vancouver Building Bylaw. The energy code that was required to be complied with was ASHRAE 90.1-2007. You may be very familiar with it. ASHRAE 90.1-1999, for those that have been in practice since then or earlier. 1999 was one of the first introductions And ASHRAE 90.1, 1999, Addendum G was the biggest introduction for controls. So we had lighting and some lighting control requirements that were introduced, a lot of architectural requirements, glazing, performances on wall that were introduced. And then in 2004, which was the next big iteration of ASHRAE, mechanical was overhauled. So mechanical systems got much, much more stricter to comply with for the energy code. In 2007, when City adopted that, back in 2008 was the adoption. It was very simple, very minor changes on mechanical, little to no on architectural other than vestibule requirements, which is why all the condos downtown have 1,999 square foot for a lobby and not 2,000, because then you need a vestibule. And electrically, not much, 10% reduction in LPDs. And for anybody that doesn't understand the LPD, it's lighting power density. Really, it's the amount of energy I can consume. So they put a restriction. There always was a restriction, but the restriction got tighter on the amount of energy we were allowed to use in facilities. Compliance forms. So the City of Vancouver has always been a leader in some of the energy and some of the, I'll use the term loosely, the red tape departments. So the authority having jurisdiction has always found ways of implementing practices so that it makes it easier for the design and construction community. So I commend them on everything they've done, including the next iteration, which we'll talk about. Back in the day, what we used to do for a building permit is, for any of our designers, we would set a building permit date, we would produce a set of drawings, we'd stamp it, sign it, prepare a Schedule B1 and B2, now it's just a Schedule B, and we'd submit it to the city. We'd get a letter back on some projects that went through the whole plan checking process, and they'd say, demonstrate your energy compliance. So all we really used to do was type a letter, put the company letterhead on it, I, Sonny Ghataurah, as the electrical engineer of record, have designed our systems in accordance with ASHRAE 90.1-2007, sign at the bottom, stamp it, send that letter into the city. The city got a letter and some records saying we have designed to the energy code that is in effect. In our previous life, before AES, I used to be with Stantec, which was an acquisition through Kane Engineering. We helped the city in going through doing some audits of some of the facilities. So of the 100 some odd facilities that we audited, 90 some odd facilities did not comply. Exactly. Did the design community fail? No. Did anybody forge any documents? No. Everything was done in accordance with what was submitted. So the design did comply with code. The design did comply with energy requirements. But what happens is the things that always happen on projects: change orders, shop drawings. So I specified air handler X, air handler Y saved me $80,000, but the energy performance went down. I specified lighting product XYZ, but I got lighting product ABC. I saved $50,000, but the energy consumption went up because the ballasts are cheap or the lamps are poor or whatever the requirements have changed. Walls have moved. Anything has changed through the construction documentation phase, and nobody has gone back and checked, hey, by moving this, does it deviate from the initial intent of the design? And that's what's changed in the new process. So as we talk through the slides, and we've got 36 or 37 slides here, if anything you want to take away from this, it's the process. Whether I need a sensor, whether I need to dim the lights, whether I'm turning off receptacles, give me a call, I'll tell you what you need to do, no problem. But the process, setting the schedule and what the requirements are and how it changes the industry, that's really the main takeaway. And a lot of people are not looking at that aspect of it, and then you get caught because you're not getting an occupancy permit or you're not getting a building permit because we haven't followed the rules. So what they did when they found out that a lot of buildings didn't comply, they introduced in 2011 and then enforced it in 2012 in September, where we had to complete ASHRAE forms. So if anybody's done a project in Vancouver in the last 2 or 3 years, for a smaller renovation under the TIPS program, you may not have had to do it, but on any decent sized project, you will have had to fill in the energy requirement, the lighting power density, what controls were, you sign it, and you send that in with your permit documents. And then verification was required at the end of the project to make sure you did comply with it. If anybody has not done that since 2012, it doesn't mean that you didn't require to do it, it just means you never got caught. Your plant checker didn't check it, nobody looked at it, or it got missed, or it slipped through the cracks, right? So I tell a lot of my clients very often the speed limit in the city of Vancouver and most of Lower Mainland is 50 kilometers an hour. How many here do 50 kilometers an hour? I'll be damned if I see one hand up. We tend to go a bit faster. We tend to do different things. It's not a problem until you get caught. So when you're doing 80 and you get pulled over, that's when it's a problem. That's what this is all about. So in British Columbia, jumping right into BC, it's 2012 BCBC. That still is the current building code in effect. However, the energy code requirement under BCBC is ASHRAE 90.1-2004. Again, very, very relatively easy code to comply with, electrically speaking. And today, looking at almost a decade out, it's very easy to comply with mechanically and architecturally as well. So as we come since December of 2013. So why December 2013? In March of 2013, Mr. Coleman issued what became law at the end of that year, a new requirement under Part 10 of BCBC and Vancouver Building Bylaw. So many people in here may be familiar with Part 3. Part 3 is safety and life safety and fire alarm systems. Part 6 is plumbing. There's many other parts in the building code or Vancouver Building Bylaw. Part 10 is the energy code. Part 11 is alterations and if you're going to do voluntary upgrades. Part 10 is within the building code and the Vancouver Building Bylaw. It's always been there. And it's always said the older code requirements. No one's ever looked at it. We only looked at it when we got rejected during a plan check-in when we made a submission to the city or the authority having jurisdiction. It's always been in the code, which means we've always had to comply with it. And that's the part that Ark was talking about. Know what's in the code, know what you're designing to. And when you leave and go back to your office, flip over to Part 10 and it'll tell you what you need to be doing in there. I'll skip City of Vancouver. I'll jump to BCBC. It's 2012 BCBC. I've already mentioned that. ASHRAE 90.1-2010 was in effect since December of 2013. That's 15 months ago. And a lot of people are still struggling with it. We've got a client where we're helping the authority in Burnaby. The client lease ended or is going to end on Friday. It's the end of February. They don't have a swing space to move into. The place they're moving or supposed to be moving into, they're going to be 3 to 4 weeks behind because they didn't comply with any of the energy code requirements and occupancy will not be granted. These are the struggles that people are facing, and as a design community, it's up to us to advise our clients. Whether they choose to accept it or not is a different issue, but we have to advise our clients of what the risks are by not complying. Compliance forms. Has anybody done a compliance form submission outside of the City of Vancouver? If you're, no? Okay, so it's coming. If you're in the City of Richmond, District of North Vancouver, City of Prince George, and City of Victoria, you have compliance forms. What the District of North Vancouver has done, and after our meeting for the inspection authority, we've actually met with them and said, guys, don't come with 10 different forms for 10 different cities across Lower Mainland. Come with one and stick with it. So the one we've proposed to them is the one that the City of Vancouver has adopted. It's very straightforward, and it's a transpose from the ASHRAE form. So it's very, very identical to what we've always done. So District of North Vancouver requires an energy model where you're demonstrating 5% better than code on the energy model. Now tell me, who's going to come up with an energy model for a 10,000 square foot, 2-story building you're going to build on the boulevard? Nobody, because the fees for a model are $50,000. The fees for all the professionals may not even add up to that for a cold shell building. So the requirements, they've just put it in, it's a blanket statement, and if you're doing a big building, we're doing a high school in North Vancouver, Bodwell High School. It's about a 50,000 square foot building, about a $20 million project. Makes sense. We want to go for a LEED Gold target. That's what the owner wants to do. It makes sense. You submit the model into the city. But for smaller projects, it makes absolutely no sense. So what we are doing is educating the regulators with the help of ARC in going around and telling them you can't push the one solution on everything. It doesn't work for all projects. So right now, if you haven't been requested for some of the forms and some of the compliance documentation, it doesn't mean you don't have to comply with code. Again, going back to the speed limit requirement, speed limit's 50. You can do 80 all you want. Drive out of here, out of the convention, do 80 all you want. Until you get pulled over, it's not a problem. So compliance with code and compliance with the design is our responsibility as a design community. For the architects in the room and the interiors, I'm not sure what you have on your schedules, but for the engineers, under VBBL Section 6.9 and under BCBC Section 6.10, they have added a new line item, compliance with Part 10/ASHRAE or NECB requirements. So that is up to the design professionals to sign off and accept that you have designed in compliance with the energy code. That's the way everybody has forced it. So when you work on a project and you may get a lot of pushback from your engineers, they're not pushing back because they're putting sensors in or designing for the fun of it. we have to comply with code. I'll lose my license as an engineer if we don't. That's where this is coming from. And the forms will help through the process, and we'll talk about why. Compliance forms in the City of Vancouver. Before I get to that, Vancouver Building Bylaw has been released. It was supposed to be released last year, which is why it's titled 2014. It was released January 1st of this year. It's at the Queen's printer, and whenever they issue physical hard copies, we'll all get a copy. Right now you can get an online copy. We've got a few as well. The Energy Code in City of Vancouver has been in effect since January 21st, 2014. We have a few clients here, one of them which we're helping the authority get through. The consultant is not from British Columbia, the client's not from British Columbia, the tenancy is in British Columbia. They submitted their permit package for 32,000 square feet over 3 floors in an office tower in November or December, and this came out and they're saying, well, the bylaw changed, but we submitted before the bylaw. And the city's saying, no, the bylaw changed, but the Energy Code's been around for much longer than that. So that causes issues with building permit dates and occupancy dates. So just be aware of what's around and what you have to comply with when you are submitting a package. With conditions, I've put behind the Energy Code, and I'll talk about that in the next few slides. There are some conditions on how they have framed it, and I think what they have done is the best thing for the design community because they've taken a TI, like an alteration, simplified that. They've taken a big project, and they've made all the requirements for that one different than the requirements for an alteration because it doesn't make sense to make them all the same under one umbrella. So I think it's a great move, and we're pushing and educating a lot of the other municipalities to be adopting the same thing. The last one, compliance forms. So now, I talked about the compliance forms that we had to submit previously, and I talked about the completion at the end. The process is now even stricter. We start a project. I'll use a very, very high-level example. 100,000 square foot facility, any type of facility. Could be an office, could be a school, could be university, research, healthcare, whatever you want. Make it whatever you want. It's about 100,000 square foot, very easy number to work with. On some of the projects, at least in the last 10 years that I've been in consulting, we have yet to design where we get a 2-year design window and the contractor gets a 3-year construction window, and then we get time to fix the bugs at the end of it and then move in. All that's now condensed into a 3-year schedule and figure it all out and chop it up whichever way you want. So we have alternate procurement and alternate packages. What we have done on some projects over the past few years, and it's actually more than 6-7 years ago now, when we go for a building permit, at times the design is not complete. So what we do is we submit for a building permit package and demonstrate compliance with the minimum requirements of code. And keep that word in mind, minimum, because the word minimum is now changed by definition for what to include in the word minimum. It used to be life safety. So design drawings used to have handrails, minimum corridor widths, and your exit and your structural requirements. Electrically, fire alarms, some emergency lighting, some battery packs, we're done. So our design documentation was no more than 70% complete. Because what do we do in the last 3 weeks before we go for tender? We figure out the lighting, we figure out the controls, because that's when the design communities figure out their finishes, the furniture, and everything else. So that period between submitting for permit and submitting for tender, depending on the design team, can be as tight as 3 to 4 weeks, and we've seen up to 6 to 8 weeks. That is no longer the practice, and we have not done that for the last year. It is one and the same, and I'll tell you why. When we go for a building permit now, I have to comply with all requirements under the code. It's not just Part 3, it's also Part 10. Part 10 used to be basic lighting. Part 10 now is the new requirements under ASHRAE, which we'll talk about in about 5 or 6 slides, which requires controls. I got to have my lighting design complete. So I'm working with the interiors group, making sure your furniture is designed, because if the furniture is this color, I need a lot more light. If the furniture is lighter and bright, I need a lot less light. The lower the lighting, the more energy we save, the more compliance we can demonstrate on the documentation. So I need to have my lighting done, my lighting controls done, my receptacles done, my circuiting done. Basically, with the exception of a book or a drawing specification, my drawings are 99 to 100% complete. And in the last year, every job we've submitted, whether it be VBBL or BCBC, we have a complete package going in for building permit, which means the permit date acceleration of 6 weeks prior to a tender date, now it's one and the same. So you've lost essentially 3, 6, possibly 8 weeks on your front end because the documents have to be complete before we go in for a building permit, because I cannot give you a schedule saying I've complied with the requirements of energy because it's now in my schedule. So life safety and minimum includes more than life safety. It's life safety and energy. So that's why I've lost that time period up front, and that's why I'm saying of all of this, we can tell you where to put sensors later on. I can issue a one-pager. That's very easy. This, where you sit and talk to the owner and say, Mr. Owner, I can get this done in this amount of time. Well, you now need about anywhere from a month to 3 months more, depending on the scale of the project. So 100,000 square foot facility, you're adding 3 months to the whole schedule, or you're designing and implementing the way we did it more than a decade ago. On the project completion, verification at project completion, we'll talk about some of the forms, but there's 2 parts to it. So under ASHRAE, which is one of the requirements under the new building code, section 944 requires fundamental commissioning. Fundamental commissioning is now part of code. How beautiful is that? We never get commissioning done on a project. I've yet to finish a job where the lighting controls work exactly the way the lighting controls were designed. Has anybody worked on a project where the lighting works exactly the way it's designed, or the HVAC works exactly the way it's designed? It's never balanced, nothing's commissioned. We cram people in, do provisional, get life safety, spend 6 weeks doing substantial, do a 3-2-1 deficiency. Then for the next 6 months, I'm chasing the contractor for as-built, he's chasing the supplier for O&Ms. Everybody hates everybody, we've all lost our fees, there's no money left, and we start the next job, and the owner goes, hey, where's my stuff for the last one? Oops. That's the flavor of construction industry in British Columbia, in Alberta, in Canada, US, in the world. It is a problem everywhere because we've said we can do it faster, quicker, cheaper, better, and we've basically cut our own throat. It's not helping anybody. So what this does is helps improve that. So 944 has fundamental commissioning as a requirement, which must be done by an independent party. So I'll talk about it in about 21 slides from now. When I design a project and you want a Schedule C at the end of the job, electrically, what do we look for? We look for a fire alarm, so give me a fire alarm testing report, give me a seismic letter of assurance, give me fire stopping requirement, give me emergency lighting testing. I think that's about it. Hospital, you may have Z32 testing requirements and some of the other ones, generator, ATS testing. Other than that, we're done, and I release a Schedule C. Now, in order to release a Schedule C, I need a commissioning letter. Fundamental device-by-device commissioning. So the fire alarm schedule, which says pull station, operational. 3 seconds, check. Bell, operational. 3 seconds, check. Flow switch, operational. 17 seconds, check. And they go through device by device, and on a 100,000 square foot facility, it could be 10 pages, double-sided. We need that for commissioning, for lighting. You're going to walk into a room, lighting, check. Controls, installed. Turns off in 15 minutes, because that's what the drawings say, check. So in every project, when we do a lead project at least, everybody wants to do the flush out so we can get rid of the toxins and the VOCs and any of that construction smell. The new car smells really nice, but the construction smell isn't always that pleasant. And we always lose that opportunity on projects because we have no 2 weeks because we got to cram people in because of any other schedule delays. Those 2 weeks can now be done. You can flush out your building because you'll have somebody walking through making sure the lights turn on and off. It's a commissioning requirement. It's line by line, device by device. When we get that, in addition to fire alarm and emergency and any other life safety items, then you get a Schedule C from us. You take that Schedule C with a prime consultant Schedule C, you give it to the city. The city now has an occupancy checklist. There's a building permit checklist. Before you get a building permit, there's now an occupancy one. This is part of it. Then they'll come out and do a final occupancy and give you a schedule. So the old days of move people in, life safety, spend 6 weeks, and then all the things that we don't really like to do and never get anything done afterwards, it's all compressed. So in my opinion, it's the best thing in our business because I can finish my design complete, I can get the project done, the O&Ms are done, as-builts are done, commissioning is done, I walk away and I might just make a buck on the job and so will everybody else. This is the best thing for our business, and if you don't understand the implication of it, you may face it on some of your projects. So that's what I want everybody to take away. The importance of this is much, much more than what people have placed on it since it had been released. City of Vancouver, when we do any project, whether it's a new construction or a TI, what now is required under the new building application submission is energy statement. So in the City of Vancouver, there's an energy statement requirement right on the cover of the drawings, whether you're doing architectural, mechanical, or electrical. If you're simply replacing an air handler, you're adding a light, you're doing handrail, whatever it is that you're doing on a project, you have to have an energy statement right on it. The main reason for it, actually it's a great thing, when we go and do an upgrade on a project, so let's say you've got a tenant that's moved into a space, they moved in 2015, 3 years from now they decide to leave for whatever reason, and you go back and start doing a TI, you may not be aware of what they've designed to, and there may not be any documentation around what they actually have designed to, because nobody's captured it anywhere, or there's no records at the city, the design firm may not be releasing any information. So when you get as-built drawings of a project, and through the series of the upgrades, there's always going to be an energy statement right on the drawing going forward, and the energy statement will declare what building code you designed to and what energy code you designed to. And that is a requirement now for all projects in the city of Vancouver, and it's going to be implemented in other jurisdictions as well. And again, whether you're doing a TI or a brand new construction, you need energy statements, and once we get this up and running, I can display what we're talking about. Compliance forms. Compliance forms are similar to ASHRAE 90.1-2010 compliance forms and documentation that we submit for a project under CAGBC or USGBC. So if anybody's done a LEED project, I'm assuming a few people have done LEED projects. When you do the documentation that's required under the minimum energy performance in LEED, there's a whole bunch of, there we go, thank you very much. It'd be embarrassing if technology didn't work for a presenter talking about technology, wouldn't it? There we go. So that's the compliance form for the energy statement. So the energy statement is required. This is strictly electrical. You have one for architectural and mechanical. Here's your building bylaw. These are the codes. There's a pull-down menu. You can select whether it's prescriptive or whether you're doing a different methodology of application. And based on what you have in here, the plan checker will take that in. There's other forms that you have to add in addition to it, and this is going to set the stage for the rest of the project. So we have to be, it's a self-declaration, and we have to do it on every single drawing in the package. The other item on the code, and I'll talk about it later on as well, you cannot mix and match. So we cannot use ASHRAE for architectural and mechanical and use the alternate, which is the NECB for electrical, because it's less stringent. It has to be the same code that you're applying with for the building or for the entire project. No picking and choosing, it's not acceptable. And if you read the excerpt in ASHRAE and in NECB, right in the front it says you cannot mix and match. It has to be the same for all. Detailed documentation, we talked about the forms. So I think what they've done here is we've been playing with it now for about 6 weeks. There's a feedback loop into the city where if you don't like something or if something is onerous or it's not easy to work with, you can send feedback. Usually response time is less than 1 day. I know it sounds shocking, but less than a day the city does get back to you and they do update and send you the link that, yep, it has been updated. So we worked with the forms before and we couldn't play with some of the menus. The forms were not easy to work with. They've converted everything from a PDF format to an Excel format, so you can do the form in Excel, email it directly to the city. You don't need to send in hard copies. So they've simplified the process and they keep it on their file for records as well. There's a new one for construction, brand new construction. First TI, so the difference between the two. 745 Thurlow, brand new office tower. New construction, warm shell. Warm shell is a T-bar ceiling with some lights in it. Cold shell is minimum code concrete and just life safety. First TI is the first tenant that's moving into the space. So it is treated as an extension of the new construction. So a brand new building or a first tenant improvement is the same thing, but it's less stringent. So they've come up with a new process, but really you're treating it as an extension of the base building construction. Alterations is everything else. So alterations is part 11, and we'll talk about that as well. If you're doing change of occupancy, you're doing a TI, you're doing a major expansion, you're adding to the building vertically or horizontally, it is all under alterations. It's very, very, very much more simplified. So new building and first tenant improvement, you're complying with part 10. For the energy code, everything else is part 11. The link below, if you want to Google City of Vancouver Energy, the first page that'll come up, it'll bring you to this page for the city. It explains all the process. There's a tutorial, there's websites, there's links to a dozen different pages. Basically very, very well done, and it explains everything around the process from the city's point of view. What I'm trying to explain is everything around the design community and construction community point of view. The form itself, if you're unable to see, but you have done a LEED project, the very top portion right up in here is where you fill in the building information overall R value, U value, skylight information. If you're going for rezoning, submit your 6 points under LEED Gold or better than the baseline under LEED and ASHRAE, and you're meeting a minimum LEED Gold performance. That's also now changed in the City of Vancouver. Instead of the 6-point baseline, they're now doing 22% better than baseline. It's exactly the same, but they're quantifying it in percentages rather than just saying number of points in the LEED system. Then the ASHRAE 90.1 compliance path, prescriptive, or you're doing an energy model. What are you submitting in here? Which professional is it? And the letter of explanation, etc. So this is the cover sheet. I fill it. Goes to mechanical, goes to structural, goes to envelope, goes to the architect. Architect is usually the prime consultant, and they take it from there and go forward. That's one of anywhere between 25 and 50 pages for documentation on that 100,000 square foot facility. On a TI, it can be simpler, could be possibly 5 to 10 pages, but on anything brand new or anything of a decent size scale, it's a lot of documentation, which brings me to my next point, which we'll talk about shortly. Building permit stage, right here. So in addition to the form that we submitted earlier, there's one for a building permit stage. We fill in all of the requirements. Under lighting, energy statement on drawings. If this is not checked off, plan checker won't take your drawings in. Next line item, lighting compliance documentation. You can click it, download an Excel spreadsheet, fill in all the information. It's identical to the requirements for ASHRAE if you're doing a LEED project. It's also very similar to the requirements for BC Hydro if you're going for a Power Smart rebate program. So once you fill in one form, you can transfer all the information back and forth. And then down here, this is what's new. If you could see the occupancy stage. So occupancy stage, and right there. First box, building permit stage submission is complete and accurate, no revisions required. Anybody filled one of those yet? Exactly. We have 3 under our belt. That is the way we want to be going, because if you don't submit that one, the next line item that we're looking at, submitting revised deliverables. So if it's all revised, take an example. You get a lighting package, and we specify 3 alternates. I pick the one that we want. It works for the architect, works for the designer. We detail everything around it. And I pick 2 others. And of the 3, I take the one that consumes the most energy on the input side on the ballast. I take that, I put it into my forms, I fill everything out, and send it to the city. You submit an alternate lighting package, the alternates are going to change because the alternate lighting package may not comply. So let's assume it doesn't comply. Your engineer accepts it. You have to then go back, and on the form here, under occupancy, you're going to pull down, and the first item will be lighting. And the next item, revised documentation. All the drawings that are affected under the revised documentation will be listed there. And then you're resubmitting all the compliance forms before you get an occupancy permit. So the implication of changes during design, it's okay to move a wall. The city's not saying don't do that. As a professional, we're not saying don't do that. But wholesale changes to the design, whether it's a lighting package, carpet package, and yes, carpet matters because the reflectivity matters on what I do for design. What you do in your construction phase has to be reflected back to the city if it deviates from the design phase. And that's probably one of the most newest things that the City of Vancouver has implemented. Other jurisdictions will be doing the same. From our point of view as a design community, best thing ever. Lighting, what we are doing for lighting and lighting controls, we're putting one package in, we're putting alternates in, and we either specify and approved equal, or we'll give a performance specification. Walk into a room, lights must turn on, manually or automatically, lights must turn off. So we prescribe it and then wait for a package to come in, or we'll be very specific for what we need. If after the job closes, contractor wants to submit a different package, we charge a fee to review the package to make sure all the energy compliance is met, so the watts per foot has not increased. Then we charge an additional fee to refill all the forms. And to give you the example again, 100,000 square foot facility, for any type of facility, I've got a person in the office for 6 or 7 days filling out the forms. And it's not a requirement just for City of Vancouver, it's a requirement for us as a professional engineer, because I do my peer review by making sure sensor required, yes. Did I put it in? Oh, we missed it there, let's add it there. So it serves as our peer review process, so we do it anyways, and it's now required by the City of Vancouver. So if an alternate package is going to be submitted way afterwards and there's some savings to be had, great, savings should be taken. But you have to incorporate the fact or include in there the additional cost for redoing the process and filling in all the forms for permit or for occupancy. That's what's new. Lighting documentation, this is an example. I've taken it right from ASHRAE. It's ASHRAE 90.1-2010. These are 4 pages, and 4 pages, we never do 4 pages. If you look right here, the first one is building area method, the next one is space area method. For the non-electrical folks in the audience, the building method is so many watts, so many square feet, so many watts per square foot, and I end up with a number. So bathroom consumes so much power, corridors, boardrooms, etc. At the end, I get a total number of wattage. The code prescribes what the maximum number can be. Provided I'm below that, no problem, I comply. But I can't just work on a building method because I now have to introduce controls in my design. I have to have occupancy sensors. I have to have daylight sensors if I've got windows around the perimeter. It's required by code. So I don't do a building method anymore. I do a space-by-space method because an occupancy sensor in a bathroom works great. A vacancy sensor in a bathroom does not work great. We don't want to touch anything in a bathroom to turn anything on. It should come on automatically. So I have to go space by space and fill everything out, which is why we do it. And on a space by space, on the 100,000 foot project, this is anywhere from 6 to 16 pages. Depends on the different type of luminaire packages we have. We may have 50, 100, 200 different lighting types like we did on aquarium, or it could be your standard 2x2s in one spot and downlights elsewhere in a strip mall as an example. So this is the documentation that we're talking about. The documentation for ASHRAE is similar whether you go for new construction, first TI, or alterations. There's no difference in any of it. This is your first TI BP form. Again, the same thing at the very top. It talks about building permit. I fill in the information, and then on the bottom, it's occupancy. So occupancy, there we go. Occupancy is the same thing, compliant with building permit or non-compliant with building permit. So you may have to resubmit anything afterwards as well. What they've done is reduce the requirements under this one, which are not as onerous as a brand new construction with the additional form in front of it. Alterations. So Part 11, if anybody's familiar with Part 11, all they've done is they've taken everything under Part 11, which had to do with F1, N1, S1, so structural requirements, fire safety, minimum corridor widths, handrails, etc., and they've added the energy component in there. So Part 11, very simply, comprises of 3 parts: rehabilitation, change of use, and the third component is additions, vertical or horizontal. You have a flow chart for each of them. I've just picked one of them in the interest of time because we want to get through the rest as well. First one is voluntary upgrade. You got a few million in the bank. You want to upgrade a building? Great. I've yet to do one of those. Next one is a small suite or a repair. I'm in a convention center. There's the exterior wall. I want to move the wall 2 feet over. It's a small repair. So it's very, very low requirements. Next one, for all the interior designers in the room, minor renovation is basically all single permit tenant improvements. So if a TI is half a floor, 1 floor, 10 floors, it's 1 TI, it's a minor renovation. As soon as you do multiple TIs, so a tenant buying and subdividing or leasing, and then they want to subdivide their space for further TIs, for further different type of occupancy, office, restaurant, whatever, hotel, you have to go under major renovation classification. The last one on the far right is reconstruction. Reconstruction, gut to the stud. You're going to gut all the way to the core of the building, and you're going to reconstruct everything. Brand new glazing, brand new electrical, mechanical, etc. That's reconstruction. The energy requirement under that one is E6, which is basically all of ASHRAE. E7 is the next level up, but another way to look at it, rather than bore everybody with the codes, is all of ASHRAE. Under minor TI, it's E2. E2 gives you a shopping list of 16 items you can pick to do. So under alterations, you have to do alteration requirements under ASHRAE, and we'll talk about that in 3 slides from now. You have to provide compliance with lighting power density. You have to provide automatic lighting controls. But in addition to that, you pick 2 items out of the 16 in the shopping list. Examples of them: make sure your exit signs are LED. Make sure your HVAC is balanced. Make sure your hot water piping has insulation. Very, very simple. We're going to do that on every project anyway. So from my opinion, what the city has done here has made it very simple and cost-effective for some of the TIs. They may not incur the cost that a 200,000 square foot TI would. So it's very easy to understand. The forms are very prescriptive. Here's an example of the form. You can't see it, unfortunately, but right up here, you can prescribe your alteration, the type of alteration you have, and it'll tell you automatically, you're E2 or E4. It'll tell you how many shopping menu items you have. Based on that, you pick the shopping menu items that you want, and you indicate them right in here, indicate the drawings that they're on, fill in all the boxes, make sure you have a reflected ceiling plan. The days of going through an electrical permit process like Art talked about and doing lighting changes to accommodate, gone. Effective April 1st, you'll see a bulletin. For now, basically, if you do not have a reflected ceiling plan, an energy statement, and any compliance documentation, you can't do any work on the lighting. That's coming, and it's enforced through this, and they're going to tie the loop on the permit side in about a month from now. So City of Vancouver is taking the charge. Every other jurisdiction is doing exactly what they're doing. The paperwork is not there today, but it will be in a few months, so it's coming. And it's a great thing from a design community point of view because it tightens the process and it simplifies it. So LEED. Why do I talk about LEED? We used to start a project and we'd ask the owner, are you looking to comply with LEED or not? And oh, well, it's an energy thing, it's going to cost me more, and so on. By constructing a project that was going to be registered and certified by CAGBC or USGBC, I used to say, or a client used to say, I've got the greenest, most energy efficient building. That no longer is the case. LEED, the current version, which is LEED version 2009, references ASHRAE 90.1, 2007. Building code, 2010. So LEED is not the greenest building you can do. Building code is ahead of LEED. It's a change of the way we look at things. LEED version 4 is going to adapt ASHRAE 90.1 2010 as a baseline. So if you think it's difficult to achieve some of the targets now, wait till you have to go under version 4. It's going to be implemented in Q4 of 2016. It was actually supposed to be in effect in April 1st of this year. The design community submitted so many changes and so many requests. I wrote about 3 or 4 letters saying, I love it, this is great, but it's such a shock to the system for people to understand building code changes. This is really going to change the game. So give it longer. They've extended the period, and it's now Q4 of 2016. They'll give it 3 months, and it's going to be likely January of 2017 before it's going to be enforced. So you can submit a project under LEED. You have a lower threshold for energy compliance requirements, but by building code, you're higher. So by doing a building to code in British Columbia, you actually exceed the energy requirements on a project if you were to comply with LEED anyway. So higher energy points, another way to look at it. The other major change, and I won't talk about LEED too much because we're here to talk about ASHRAE, there is a whole bunch of different sectors or rating systems you can work with. Before, it used to be new construction, commercial interiors, renovations or existing buildings, or MERB for multi-unit residential building. Now, with the exception of a pool, an aquatic, or a community center, I have a rating system for everything. So if I'm doing a tilt-up in Langley, I've got a rating system. I'm doing a district system, I've got a rating system. I'm doing a research facility, I'm doing a data center. Talk about energy hogs, worse than pools, data centers. So data center, I've got a rating system for that. So it actually helps you achieve some of the goals around LEED. And we'll see when the rating systems come out and how we can apply and comply with it. I'm not going to talk about the rating system in detail other than the focus of LEED has changed. Previously, it used to be energy reduction. The new approach is carbon reduction. So if you don't understand the difference between the two, when I save energy, I save some carbon because I'm saving electricity or gas. And they both have carbon signatures in British Columbia. Electricity are much lower, which is why the fuel switching has been happening for the last 4 years since carbon tax was introduced. Carbon reduction, when I save carbon, I automatically save energy because carbon reduction is approaching everything differently. That's why all the automobile manufacturers are coming out with electric cars and A series and C series and 1 series and all these smaller versions of cars because they all have to reduce their carbon emissions by 50% by 2016. So all the manufacturers have it way worse than what we have. And all we're talking about is turning off some lights. And the amount of grief we get from the community for doing that is incredible because nobody wants to turn anything off. It's got to work. Metering, the last one, it's a prerequisite in the new rating system. In the city of Vancouver, metering is also now a building code requirement. You have to have separate meters for all your different systems. They've left it open to interpretation. So you can have 1 meter and apply and they'll reject it. So you really have to break it down and use your own logic. Every time you have a separate use, so a mixed use facility, hotel, office, condo, retail, there are 4 separate uses. You need 4 separate meters. You can combine them into electrical meters or have lighting and HVAC and plug load separately. You have water meters, etc. The other one that Art mentioned about is electric vehicles. You have to have electric vehicle receptacle and outlets and charging stations in all buildings downtown, in the city of Vancouver. So these are all requirements under the new code, and LEED is also enforcing some of it as well. So aside from regulatory, which I make a big point about, we're all here to listen about ASHRAE. So ASHRAE, the biggest one other than transformer efficiencies is receptacle control. And there's a lot of pushback on it, and I really don't understand why the pushback is. I've been here since 9:30 this morning to prep and get everything ready, and the projector still failed anyways, but get everything ready, and I'll probably be here till about 2 o'clock. There's absolutely no reason on the planet why anything in my private office needs to work from 8:45, which is when I left, till 2:15 when I get back. Neither the lights, the task light, or my monitor. Many people in their offices have, whether open or private, humidifiers, little portable heaters, little bar fridges, little any other thing that you have. You don't need them running if you're not at work, and you don't need them there operational if you're not there using them. So what we do is we have to turn off receptacles, 50% of them in office spaces and in classrooms. It's a requirement under code. So in our design, what we do is we follow the Public Works Standard. It was developed about 25 years ago. It's a fantastic standard, and it's what we do on our projects. We provide every workstation with 2 outlets, a gray outlet and a white outlet. Gray is for computers. It's a different color. I plug something important in there. And the reason we do that is I can group computers differently than I can group the rest. I put 3 computer outlets to a circuit. I put 6 convenience outlets to a circuit. So a gray and a white. And what we do in our designs is we switch the white receptacle. How do you know which one's which? The NEC now came out and adopted a new receptacle which has a symbol of an on switch on it. That's a switched receptacle. It's a universal sign. It's all accepted all over Europe, and it's going to come into Canada as well later on this year. That's a switched receptacle. You can now buy receptacles with sensors built right on it. So if the receptacle is at desk height and I'm not at my desk, no reason why anything plugged in needs to operate. Will your computer turn off? No, because your computer's plugged into the gray outlet. We are not touching your computer. But if you've left your desk and you're not there for majority of the day, or even more than 10 minutes, nothing needs to run. And that's the intent of this code. You can do it by time of day. So time of day is also acceptable, and I used to say we do that for anybody that's got banker's hours. Since the recession in 2008, I think we all work consultant hours, so every waking minute we're working. 24 hours a day, so time of day doesn't really work. We provide local sensors and turn lights or turn receptacles off as required. Lighting and alteration. So previously under ASHRAE 90.1-2007, the threshold was 50%, which meant almost every project. It was previously 50%. Now it's 10%. So the example I'll use, if you take a 100,000 square foot building, take a typical floor, 10,000 square feet that you work with. On 10,000 square feet, if you have 10,000 watts of lighting and you're altering more than 1,000 of it, you have to comply with this. So if I'm doing a TI and I've got a floor and I've got a boardroom, and the boardroom is 1,000 square feet of the 10,000, and the boardroom is 10% of the lighting that's connected, and I'm taking that boardroom, chopping it up, and making it 3 private offices or 4 private offices, I have to implement LPD, which is make sure you don't exceed the lighting power density within that space, and I have to implement automatic lighting control for the space I'm renovating, not the entire floor. So the 10% area I'm modifying is where I have to comply with it. And the definition of space is your floor, the area, the walls. You can define it any which way you want, but grossly stating an entire building is my space and I'm doing one little cubicle in the corner, so that's under 10% and I comply, that doesn't work. There has to be logic behind it. So your space is typically the area that you're in, and we typically limit it to 1 floor, so 10%. If I'm below that, I don't have to implement it. If I exceed that or at the threshold, I have to implement 2 things. One is LPD, which is lighting power density. So if the code says for a boardroom I'm only allowed 500 watts and I've got 1,000 in there, I've got to reduce it to 500. So the finishes and the reflectivity of furniture and all the finishes in the room, very important to us, because the lighter they are, the less light I can put in, and the brighter the space feels. There are exceptions, and in the interest of time, we're just going to kind of rush through this. Lighting controls. Any enclosed space requires some sort of control. So automatic shutoff is required just about everywhere. If I'm in this boardroom and I leave this boardroom and everybody else exits, 30 minutes after everybody leaves, lights must turn off. That is code. 30 minutes is the maximum the code allows. You can design it for whatever you want. In our office, for the receptacle switching, and we designed our office in 2012 when receptacle switching devices were not even available. So in 2013, when we finally moved in, we bought power bars, hardwired everything in, and we've got sensors under everybody's desk. So 5 minutes of no motion, everything except the PC turns off. You come back to your desk, boop, boop, everything's running. The cost for it, $50 a workstation. And it might seem like a lot, but the energy bill, I save about $200 to $300 a month on the energy bill on the other side, because people have, other than heaters and fridges, because no one's allowed, that's just a rule in our office, everything else is off. Task lights are off and everything else is off. So you do save on the bottom line. Control via time of day, you can do control via time of day, do a central bank and a time clock and turn everything on and off. That is a compliance method. We don't design to that. We actually design for local activity. So anything that's enclosed, I've got a local sensor. So if it's an enclosed room, I'll do a local sensor. If it's common area corridor, I'll put in a low voltage system. But typically we go with line voltage, localized control, cheaper, easy to repair, ton of product on the market. We do a 120 volt system. We don't do 347 anymore because 347 control is very expensive and very difficult to procure. There are exceptions like corridors and so on. They talk about stairwells as an exception, but it's not, and I'll explain why in a few slides. Automatic on. So anybody work in an office tower downtown where you walk into work at whatever time you do and the entire floor is lit. There are a few people that know, not very many. Good, your landlord's already gone in and implemented something. But what used to happen, if you go back to the older designs, is you had a bank of switches as you got off the elevator. You came in at 6 o'clock, all the lights swept on, and at 8 o'clock they started sweeping off. You get the flicker control to give you a warning. You went back and hit the switch to override and the lights came on. We can't do that anymore in design. It's not allowed. BMS control to turn everything on is no longer acceptable by code. Not the engineer being a tree hugger. It's a code requirement. Manual is what we have to do. So automatic control, if you are going to tie it into some sort of automation to turn the lights on, 50%. The logic behind that is if I come into an office on a Saturday afternoon because I've got to do something, I walk into the floor, I don't need the whole floor on. I need enough lights to get me to where I need to go. 30 minutes later, all turns off, and where I am is where I need the light. That's the only thing that stays on. So if you are going to design with automatic control, you cannot turn everything automatically on. You have a 50% maximum requirement. Anything beyond 50% is manual on, so switch at reception that turns the lights on. Additional LPD and lighting control. The main message to take out of this one is your watt per square foot and your watt per square meter requirement. So sticking with the metric system, we're Canadian. Watt per square meter to watt per square foot conversion, divide by 10. So 14 watts a square meter is approximately 1.4 watts a square foot. And for lighting design for an office, right now, under Thurlow and 980 Howe and any of the other office designs, we are designing to 4.6 watts a square meter with LED and 5.2 watts a square meter with fluorescent. The code is 9.7. Point being, absolutely doable, very easy to achieve. Why does watt per square foot matter to a designer or an installer or an owner? You have a maximum restriction. So it's like when I take my nephew to the mall. I give him $5. He can go buy an O. Henry bar and done with it, or dip a quarter into every machine and buy all the different candies and go to town. You've got $5. Do whatever you want with it. So on a lighting project, on 1 watt a square foot or 10 watts a square meter at 100,000 square feet, I have 100,000 watts. Do whatever you want with it. If you spend it all in the lobby and the bathrooms and the jazzy reception and make it all look sexy and nice and attractive, everyone's getting a tea light at the workstation because you got no lights. So the idea is to take the watts and divvy it up and spend it efficiently. And in order for us to do that, what we rely on as the design community is we rely on the interior designers and your finish and your finishes. The furniture, your color palettes, everything that gets done typically after we go out for tender, we need that way before we go out for tender because the reflectivity of that will drive a project one way or another. This carpet gets me no more than 30% reflectivity. If it was a lighter gray, I can go up to 55. That's a 20 to 30% difference in lighting power density. That's why it's important. So watt allowance and the amount of watts you're allowed on a project is going to become very, very important on projects. Lighting controls. There are exceptions. We have to run a business. So if I've got a retail shop, so Holt Renfrew, right along Granville Street, they've got mannequins on the front. If I've got a mannequin on the front, I've got a partition, I've got some lighting that's separate, and I've got a lighting control and a switch on a wall that controls that separate from the rest of the space, I can exclude it because it's not general illumination. So the idea is look for all the exclusions on a project before you get carried too far in the watts and the design on a project. Lighting integrated. So on a lot of healthcare projects, We build the headboard and we build everything on site, wire everything in, and that's a cheaper alternate than buying a headboard on some projects. Well, the headboard comes with a cord. If it comes with a cord and I plug it in, the light that's built in, I may be able to exclude it, so which is cheaper. That design decision gets done collectively as a team, not by one person. The last one is task lights. So the design in BC, and everybody probably remembers this term, 50-foot candles. And 50-foot candles was the number. It used to be 100, and it went down to 50, and WorkSafe BC worked with that number. Every office space had to have 50-foot candles of lighting level. So we put in all these deep cell parabolic with 2 or 3 lamp requirements with T8s or T12s, and we hit 50-foot candles. And then ASHRAE came in and lead movement came in, and we wanted to save energy. So we went from 50 down to 30 so I can reduce the illumination level so I save energy, so I can get more points on the lead system. And I gave everybody a task light. And the task light provided lighting where I need it, and the general illumination was bright enough so I can work in my space. Now, if a task light is free to walk, if it's just sitting on a desk, I have to include the wattage for that in the lighting that's built into the ceiling. So I might as well have done 50-foot candles and call it a day, but then I don't save energy. So task lights now, to exclude them, they must be hardwired. So clamp down to a desk, yes, that's a solution for anybody that cannot procure pre-wired workstations with built-in task lights. But task lights that are built into a workstation, manual on switch, and automatic off sensor. If you have that, I can exclude the task lights. So for the designers and the furniture suppliers in the room, the FF&E discussion happens way after we start construction. I've issued IFT, I've issued IFC, everybody's already started ordering and building raw construction, and then we go and procure furniture. Furniture, I need to know at the beginning of the project what you're going to do with furniture. Is it pre-wired? Is it not? Simple decisions, not Hayworth or what manufacturer. Pre-wired or not, you're going to get task lights in or not, what's your reflectivity on the furniture? So those decisions need to be done up front. And why is it important? If I have a built-in task light with sensors included, I can take that furniture and relocate it elsewhere on a project. Whereas if I put a sensor in the wall and the ceiling and I do the next TI and move the workstations, the sensors are much costlier to move when they're built into a ceiling versus built into a workstation. So let's have those discussions much sooner on a project. Enclosed spaces, we talked about already. Provided you have a step somewhere between 30 and 70%, you meet the requirement. What we do on our projects, we put a dimmer. You've got a dimmer in every room. You can comply with it. Where the 30 and 70 comes from, remember, ASHRAE is an American standard, not a Canadian standard. So a lot of the American designs are still working with 3-lamp solutions. So if I turn one of the 3 lamps off, I'm at 70% below maximum. That's where it comes from. So when you understand the intent, it's easy to figure out why. What we do in design is we just put a dimmer in the room and we comply with it. You have exclusions. If there's only one fixture in the room, less than 100 watts, I can exclude it. But typically, it's not the case. You have much more than that. Occupancy sensors are required just about everywhere. So if I leave the room, I need an aux sensor. In our designs, we use vacancy sensors. We don't work very much with occupancy sensor unless I'm in a bathroom. Main reason being, almost every project I pursue a PowerSmart hydro rebate or a credit back from BC Hydro. And hydro will work with anything that you do above and beyond baseline. So if baseline says you must put an aux sensor in, you're not going to get a credit for that. Vacancy sensor is a credit. So the difference between the two, an occupancy sensor is automatic on, automatic off. Vacancy sensor is manual on, automatic off. I've got a corner office facing Granville. It's always lit between 8 a.m. and 5 p.m. My lights are only on when I get in at 5:30 in the morning, and by 8 o'clock I turn them off. Or the daylight sensor kicks in and turns off. So any other time of the day, if I come in and I need light, I hit a button and manually turn the lights on. So the idea is if your space is well lit, you don't need to turn the lights on. So that's why we use vacancy sensors. There are exceptions, but basically, if you've got glazing around the perimeter and you've got a workstation around there, you've got to dim the lights, and it's got to be automated. You can't do it manually. Parking garage, the most controversial one out of everything that we've got to do. All parking garages, we've got to turn the lights off. It is a requirement. Read section 9413, subsection 1, which says comply with subsection front end, and the front end says everything must turn off after 30 minutes of occupancy. So in our design, what we do is at 20 minutes, we provide a flicker, and the lights give you a flicker. So if you're in there, it stays on, and there's occupancy sensors everywhere. If you're moving in the parkade, it's on. But at 3 in the morning, all the office towers downtown, there's no reason for any of the lights to be running because nobody's in the parkade. By code now, we've got to turn them off. And if you design a parkade like that, first of all, you'll never get that many lights in the parkade. Second, nobody wants to park whatever they drive in here, whether it be a bicycle or a BMW. Doesn't matter. Nobody wants to go in there. It's not pleasant. This is what we want to be doing, which means I've got to paint the walls white. I've got to paint the ceilings white so I can create a higher level of brightness, so I can meet SEPTED requirements, so I make sure I meet safety requirements, so I can reduce the LPD, so I can put that LPD on other things like signage or graze the building or any other architectural intent that we want to try to meet. And that picture on the right, by the way, is a project in the US, Midwest, and done for 35,000 square foot a stall. $35,000 per stall. And the budgets we use in the city of Vancouver are $40,000. So it is very doable. It's not something that's far-fetched. Lighting controls, exterior lighting and building lighting. So building lighting, if I'm using it to illuminate a building or a feature, or I've got landscape lighting that's not required for pedestrian or exit. So anything that's required for accent or illumination or grazing or providing bling, as they call it, to the building, I've got to turn it off at night. So the picture on the top right, completely lit. During day hours, it's okay, or during occupancy hours, it's okay. Bottom left is where we're going. Everything must be off at business close or 1 hour after or by midnight unless you run 24 hours. So there are exceptions. Prisons, RCMP, hospitals, they are exempt. But most facilities, we've got to turn it off. The next item is signage. So in signage, we've got to reduce to 70% illumination. So if you've got a building sign on the top of a building or at the front or anywhere around your building, you can have it lit after hours, but it must be dimmed down so that you're not bugging your neighbors and you're not affecting animal wildlife as well. So this is code. This is not us being energy efficient and trying to push the envelope. This is the baseline. We've got to go above and beyond this. Lighting controls, for anybody that does hotels and guest rooms, you walk into a guest room. So if you go down on holidays, if you go down to Mexico or the Caribbean or anywhere in the warmer than here climate most of the year, you leave your room, you pull out your guest card, everything turns off. That's where we're going to end up in 6 years. Right now, I've got a master kill switch. So I walk into a room or walk into an apartment or a hotel room, I've got a master switch that provides the power to all the rest of the lighting in the space, and then I can further go turn things on and off. When I leave the room, I hit the master switch off, kill all the lights in the space. That is code. And all hotel chains are now implementing it because they've saved a ton of money. And the ROI that I've been given on this requirement is about 6 months by every hotel operator in BC, based on our low energy rates. So it is worth doing. Task lights we've talked about. Stairwells. So stairwells, we have to reduce the level of illumination in stairwells down to 50%. So all the stairwells in all the office towers in a downtown setting or a suburban setting that nobody ever uses because we're so dependent on the elevator or the internal staircase if you've got a fancier office with an internal staircase. You may not use it, which means it's always lit all year round. The only time you go in is when the landlord makes you do a fire drill. Other than that, nobody touches it. Now we've got to turn the lights off down to 50%. In our designs, we go down to 10%. If you walk into a landing, the light comes on, the one above and below the lights come on. So if this landing, the light fails, the one above and below are lit, get you illuminated so you can exit the building. But dimming for stairwells is code. It's not something we are trying to do to save energy. Mandatory commissioning, I talked about it at the front end where we had to do mandatory commissioning. So if you read the line, includes functional testing and must be an independent agent. So on a LEED project, we have an independent commissioning agent that does all the commissioning. We include in their specification to do the lighting as well. If you're not pursuing a LEED project, you still have to do this. And it's not me, and it's not Tony doing the lighting supply, and it's not Craig doing the lighting installation. It's somebody that's independent to the project. So you have to get an independent person come on board. And we're not talking about somebody that's certified in a level of detail that's beyond what we already do. It's lighting installed, yes. Controls, yes. Works, yes. Give me a letter, make sure it's done. That's all we want to do, make sure it's commissioned. The other one for anybody that specifies elevators, and the reason I throw it up is nobody looks at Part 10 of ASHRAE 90.1-2010. Part 10 is for other equipment. Under other equipment is elevators. So elevators, now, if you specify an elevator, it must have a shutoff for all the lighting in the elevator and the fans in the elevator if the elevator is in standby for 15 minutes or more. So why I mention that, you can still buy old product, and if you specify that on a project, and Sally's laughing because we can't specify it on a few projects, The inspector at the end of the job, when he comes in for a final permit, you may be pulling that elevator out. There's one project in Vancouver where that is occurring. I won't name it. Very unfortunate for the owners, but it's code. You have to do it. So don't buy an old product. Make sure you're up to par with what's important. So, who cares? Why does all of this matter, and why is it a big deal? I'll give you one very, very simple example. We did a project where I worked with the architect. No ceilings, concrete, very light coating on top. All the finishes were approximately 70% reflective, lighter whites, lighter browns, no grays. Carpet, very, very light gray. We worked with all of that, and the requirement from day one, suspended fixtures, no hot spotting. I don't want to see the strip of light when I'm driving by on the highway, the bang, 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 and I can see the illumination. I want an even graze across the ceiling. So we picked the right reflectors, we picked the right fixture, and we worked very closely. We did 3 mock-ups, we got it all done. And then at the end in the project, we weren't informed, but somewhere through the process, the designer accepted a change in the carpet from light gray to dark maroon and shaggy style. So the reflectivity of a light gray was 50-55%. The one they accepted was 0. They saved $50,000 because that was the savings passed to the owner. The owner then spent $58,000 on a change order to convert all the lamps from single to 2 lamp solution. So he spent negative $8,000 to get a substandard product, and now I get shot every time he drives by that building. Sonny, that light, nothing I can do. Moral of the story, if you make a change to a finish, let me know. It makes a huge difference on the lighting for the project, and it can destroy your entire vision of what you're doing for the building. That's what this is about. Budgets. We start a project, the budgets are beautiful. At the end of the project, they all change because requirements and what's important changes. So controls are not expensive. And anybody that supplies and installs controls, they'll tell you they're not expensive. It's about $1 to $2 a foot on the overall budget of whatever your budget is. Could be $60 a foot, could be all the way up to $100 a foot. On a brand new build, purpose-suited building, maybe $300-400 a square foot. So $1 to $2 is not much. But that's where we start. And the first value engineering option provided by everybody on a project is controls, take it all out. You can't do that anymore because the 25-cent solution that gets me a switch on the wall, no longer compliant with code. So if you stick with the budgets you start with and look at other ways to pull money out, no problem, you can comply with it. Lighting concept, I put this picture up really simply because the top right picture is a picture of a project we're very proud of, Ritchie Brothers in Burnaby. We worked on it in 2004, designed it in 2006, moved in 2008. The code then was ASHRAE 90.1-2004. With the exception of receptacle control, that building is compliant with 90.1-2010. 8 watts a square meter, everything dims, everything turns off, everything's inclusive in the project. So it is doable. It's very, very achievable. This one is a department store that I'm sure everybody here has shopped at, and it's one of many department stores. They all kind of look the same. If you look at that, I've got cove lighting right down the middle, cove lighting down here. I've got 2-foot fluorescents. I've got grazing along the wall back here. This is approximately 32 to 35 watts a square meter, which is not a problem for retail. What's the code now? 15. So when we're designing Lululemon on 4th Avenue and when we're designing Blends Coffee on 2nd Avenue, we had to have a C-level discussion with all the owners. You're going to rebrand. And why do I have to rebrand? I've been doing this successfully. Well, if you want a store in British Columbia, you're rebranding because you're not going to get a building permit. So Nordstrom had to change their lighting and how they were going to achieve some of their stuff. We're working with Microsoft now on the top 2 levels of the Nordstrom building that they're moving into. It's a wholesale overhaul to Microsoft standards that they've deployed in North America for the last decade. It's not a bad thing. It just means you can't do what you've done for the last 20 years because it's worked. It's not going to work anymore. You've got to look at more innovative ways of achieving the intent. So, how do I not comply? There's 2 codes. ASHRAE 90.1-2010, everybody's familiar with the ASHRAE. NECB 2011 is the other one. So NECB, if anybody's familiar with the older version, the MNECB. So MNECB was the Model National Energy Code for buildings. They've dropped the M and made it a National Energy Code. The difference between the two, ASHRAE is American, NECB is Canadian. ASHRAE is cooling climate-based, NECB is heating climate-based. So if I'm doing a project up north, Fort St. John, Fort Nelson, somewhere with a fort, somewhere where it's really cold, -30 is your daily temperature in the winter, NECB is the better approach. Whereas if I'm doing a project in Lower Mainland, where even though it's 7 degrees outside and it's freezing cold, we're air conditioning this room, ASHRAE is the better approach. So it really depends on your project. You have to look at the way that you're going to achieve the intent the best. If you're doing a lead project, you may be doing ASHRAE, so doing an NECB approach may not work, because then you'll do NECB documentation and ASHRAE documentation, double the cost. If you are going to go with NECB in the city of Vancouver, they have very prescriptive requirements around what you must do, so you can't pick and choose like we pick and choose with ASHRAE. I've got 3 slides left, and then we'll wrap up. NECB does save you much more energy, because in NECB you have a better envelope, better glazing, much better performance system around the heating and cooling of a building, whereas in ASHRAE you don't have those stringent requirements. Comparison of the two, very simple. Lighting alterations is not a requirement under NECB, and the reason for that mentioning up here is ASHRAE is applicable to a Part 3. People understand Part 3 and Part 9 building. So Part 3 is anything bigger than 600 square meters. Part 9 is anything smaller. Part 3 building, Part 9 building, and alteration, I can use ASHRAE. NECB is only applicable to brand new Part 3 building. Part 9 building, no NECB, it's not applicable. Alteration, tenant improvement, renovations, expansions, so on, you cannot use NECB. So it's not even an applicable code for many projects. So it's an alternate, but it's a very restricted alternate, right? So you can't just go ahead and jump into that one. If you are going to pursue NECB, I've talked about it already, there are much more stringent requirements around the envelope and the glazing itself, so you may not be able to comply with it. The designs in Vancouver are all glass and all wood, because we want to have transparency, open to nature, open to the views and the daylight. So you can't really do this if you're going down the NECB compliance path. The difference between the two, we modeled a project in Lower Mainland, I won't name the project, 70,000 square feet. The NECB upcharge for glazing and window wall and insulation versus the upcharge for controls. NECB was $1 million, controls was $55,000. So in our climate, it does not always work. So last slide and we're done and we can get into questions. What do you do when a project starts? Really define the project goals and what's important to the project. What are the owner's requirements? What do you want to do? Some owners want to do a live-in building project. Okay, great, that's a target. Define whatever it is you want as a target, work with that. Check which codes are applicable. I can't enforce that enough. You've got to check what code is applicable and what part of the code is applicable to your project, because it can make or break your occupancy at the end. Are you doing a LEED certification or not? And LEED is not more greener than the code, right? Decide as a team which one you want to go with. Most projects in Lower Mainland, Kelowna and South, you're going to be doing ASHRAE. Anything above that, so we're doing a project up north as well in the Yukon and Whitehorse, NECB seems to be a better approach. So we have to go down that method as a team. So look at what's better for your project. And then really calculate your watt allowance and make sure your designers know what they need to do. And then do what we always are supposed to do on projects, but don't always get the opportunity to do so. There we go.